This is part 3 in a series of videos where we are exploring microservices as a path to living software. A quick recap, in part 1 we discussed the challenges of monolithic application architectures. In part 2 we explored where microservices are used in the wild. We also took a stab at defining what exactly a microservice is, and then we wrapped up by discussing the costs and risks of microservices. In part 3, we will discuss how you might go about designing a microservices-based application, culminating in a blueprint for microservices. It turns out that all those good object-oriented principles that we learned so long ago, it seemed like solid, the single responsibility principle, encapsulation, high cohesion, loose coupling, it turns out that they apply at every level. Not just the method, the class, the package, but we can scale those principles all the way up to the microservice level. In 2003, Eric Evans came out with this book, Domain-Driven Design, and it's not the most approachable of text, but it's definitely worth reading. It introduced ideas of the ubiquitous language and bounded context. You know, I think that this approach is certainly complementary and compatible with the ideas of microservices. So if you're in the position of you want to start something from scratch and you're designing your application, this is probably a good place to start. And once you have your design, or at least the first cut of it, then you may find that microservices may just kind of fall out of that. If you are, like most folks, struggling with an existing legacy monolithic application, what you may find is how do you start kind of breaking it down and finding the seams of that monolithic application to form the boundaries of the microservices. So that can be a challenge. Recalling back to my days at the airline, as you may recall in part 2, we had 25 or 30 servlets or so. And they provide a good slice, a good candidate for kind of breaking off into their own little thing. But you may look at servlets if it's a Java web application. You may look at if it's faceless and it's just providing RESTful services. You may look at each individual controller and breaking that off. There are so many approaches you may want to consider for kind of finding the seams of what could be your microservices. Going back to if you are starting something from scratch, when you start off anything new, there's so many things you need to kind of. It can be quickly overwhelming. Trying to understand the business problem, trying to estimate it, trying to design a solution, the architecture, implementation details. Microservices may just add too much weight to that, so it's perfectly fine to kind of charge ahead with a fledgling monolithic application architecture, with a keen eye that in the future you want to kind of break that down into smaller, more manageable microservices, and that's certainly an option too. There's no real hard and fast rules. Now, whichever approach you take, whether it's an old or new application, however you choose to break down your microservices, you really do have to pay attention to how these services are coupled together. You need to be continually conscious and aware of coupling. Ideally, you want to have very little, if any, coupling between services themselves. And the reason for that is you could have an impact on availability. So here, for example, you may have heard of the 5 nines. So the 5 nines, I believe, came from the telco world. And basically what it equates to is, we see the formula there, uptime plus downtime. The 5 nines equates to 5.26 minutes of downtime a year. Now, let's look at our application we have on the left. So we have 3 microservices, and they each comprise individually, in isolation, 5 nines availability. The question is, what is the overall availability from as observed by C, the client, on the left there? So here's the formula. Basically, it's a product of the availability of all of those microservices. And so the actual answer is may not be what you expect. It actually equates to 15.7 minutes of downtime a year. So we've actually made availability worse through coupling the microservices together. So it's something to really pay attention to. There are ways that you can mitigate that. Sometimes some degree of coupling is unavoidable, but towards the end of the presentation, we'll discuss some approaches you can take to keep the microservices loosely coupled and yet still be able to kind of collaborate and share information with each other in a loosely coupled fashion. Let's probe a little bit more as to why that was the case. Why did we end up with a decreased availability and increased downtime? So here we see if you kind of have something that requires two services, in this case X and Y together, the downtime in that case, then you can see how the downtime increases to double that. But now let's look at how we can kind of scale out and add some redundancy. And we can see how when we do that, here we have X, and there's the formula for availability there. Let's say we have 2 of X. So if one goes down, we can still function because we can use the backup. So think of this, the way I think of this is like a 747 jet. They are designed to be able to withstand the loss of at least one engine, I believe, maybe even 2, and yet the plane is still able to land. Obviously, there's not much you can do if all engines go out, but you get the idea. So we have some redundancy there too. Okay, so here we have 2x in redundant fashion here. Just a single x, that would equates to over 5,000 downtime minutes per year. But when we combine them, we've increased our availability and we've reduced the downtime significantly. Now look what happens when we add 3 of x. We're now up to 6 nines and we're down to less than 1 minute, half a minute of downtime per year. But keep in mind that overall availability is reduced with each dependency. So with microservices, the number of dependencies may increase, particularly if you're not paying attention. So let's think about how microservices work together. So here's probably something that we should avoid, and this is really a smell that maybe we haven't got the boundaries correct. So here we have microservice 1 calling microservice 2 over an RPC call. It's a synchronous RPC call. So for microservice 1 to fulfill its function, it relies on the availability of service 2. You should really avoid this. And like I say, if you find yourself in a situation, maybe you've got the boundaries wrong, and maybe if they're so tightly coupled like that, maybe microservice 1 and microservice 2 just need to kind of live together, stay together. Because microservice 1 says to microservice 2, I need you, but you keep on bringing me down. So when microservice 2 goes down, microservice 1 goes down with it. If this is unavoidable, then you may want to look at the circuit breaker. So if you figured out that the boundaries are correct, but this is kind of unavailable, if you still need to do this, then you really should consider a circuit breaker. Just go ahead and Google the circuit breaker pattern, and then you can find even implementations of that. Study the Netflix Hystrix open source project, and it's just like a circuit breaker at home, in your electrical wiring at home. So this kind of coupling is let's keep this professional, says service 1, but you're still being kind of needy, says service 2. This is probably the final approach here. Is probably the preferred approach. It's asynchronous. It's a pub sub model. And we're using an intermediary, in this case a messaging backbone, that we can publish interesting information to a resource such as a messaging backbone. And you can choose whatever makes sense for you, whether it's Apache Kafka that may be worth logging into, or RabbitMQ. There are a bunch of things out there that that support this style of communication between components of a system. So here, microservice 2, don't ever call me again. That's fine. Microservice 1 says, hey, whatever, I just don't care. So they're blissfully uncoupled, and they do not care about the presence or availability of each other. They do not care what happens. They have their job to do. They emit, output their findings or their responses, or something for somebody else to pick up, and they're just kind of blissfully unaware of each other. Securing microservices. Keep in mind that the microservices really, at least in the context of taking an existing monolithic application, maybe it provides a web interface, or maybe it provides RESTful services, or maybe it provides a mixture of both. Maybe it has clients coming in, connecting to it from left and right. You don't really want to expose the innards. So, for example, if you are migrating to a microservice architecture, you don't want to impact your clients. You want to be able to kind of plug and play, replace your monolith with your microservices-based architecture. Again, following the principle of encapsulation, which we touched on briefly, the fact that you're using microservices should really be kind of hidden from view. And also, there are other good reasons why you may not want to expose your microservices individually. Anyhow, you may want to control access through a single point of entry into the system, and you don't want to kind of you don't want to punch. If you have if you deploy your monolith onto some machine that has a firewall, like IP tables or whatever, you don't want to kind of punch holes in that firewall to expose the raw microservices. So here's one approach that you may want to consider, is kind of pushing the microservices behind a thin server-side proxy. Ideally with a circuit breaker. So if one of the microservices goes down, then you don't want to have a ripple effect that eventually takes down the proxy and starves access to healthy microservices and kind of bubbles up all the way to upstream. So this is what that can look like. If you look at the proxy, again, if we're dealing with an existing monolithic application, as we carve off these microservices, the proxy could be, kind of just what's left. If you do not pay attention to coupling, remember this from part 1. This was the class diagram that is just the big ball of mud. You don't want to let your microservices turn into this. All you've done at this point is basically you've displaced complexity from the logical space to the physical space, and you will fail. So you get none of the pros and all of the cons of microservice, and you really kind of gone in the wrong direction. Let's take a stab at defining a blueprint. So what do we have here? Notice we have these circuit breakers to avoid cascading failure. So this is extremely important that you prevent cascading failures and you fail fast. This is idea really of a shared nothing architecture. Again, we need our services to be completely decoupled from each other. So each service really should have its own config set and log location to avoid stepping on the toes of other services. And this gives you some flexibility to kind of repurpose services and reuse them in other contexts too. We talked about this briefly here. No man is an island, and sometimes services have to they can't just swallow information. They may need to produce it too, augment it with some interesting facts or whatever, whatever the case may be. And you need to provide a mechanism to enable the output to be wired from one microservice and to be fed into some other microservice. So you need this idea of an asynchronous messaging backbone, and it provides the loosely coupled way for services to work together. Now, a benefit, a feature of complete independence and isolation is that each service can be tested, versioned, released independently of each other. Let's talk about encapsulation. So you're looking to eliminate side effects. So a way that side effects can creep in, and we're all familiar with side effects, within our code, but we want to eliminate side effects within our microservices. A way to introduce side effects unwittingly is this idea of a shared database. You might want to look at, can my service has its own little lightweight database? There are plenty out there, whether it's Hypersonic, HSQLDB. This might be, if you just have basic persistence needs in a microservice, then these embedded little lightweight databases could be perfect for that. If that is unavoidable for whatever reason, then and you do need to have a shared database, then at least consider how you might carve up the schema within that database. So the tables within a database are not shared between services. Again, services should have a single responsibility. In this example here, we have a service that has responsibility of providing an integration point. So a lot of the products and systems I've worked on in the past have in them either inbound or outbound integration points, and a service is for each of those flavors of inbound, outbound integration points is perfect for that. But if the service is in support of an API, a RESTful API, or in support of a web application, then you probably want to tuck those behind a proxy. Again, we're thinking about running these services for the most part potentially on a single box. So again, approaching this from the direction of I have an existing monolithic application which is deployed on a single box. Of course, those boxes could be replicated for redundancy purposes. So we anticipate that if you take that single monolithic application and kind of carve it up into services on that same box, then this is good. It gives you the opportunity to you really want to tune those services individually, and so they can allocate only what they need. And of course, each service has its own automated regression test suite. So in this particular blueprint, again, approaching from the direction of taking an existing monolithic application that is deployed on a server, here's how we may carve it up. You want to avoid really having, for example, the proxy run on one machine and the services running on a different machine. Be aware that the microservices architecture may introduce some latency, so you can mitigate that latency by ensuring that, at least from the proxy to the microservice, that is a local connection. And of course, for redundancy, this model you'd replicate over and over again, just like you'd scale a traditional web application or enterprise application. Looking back at the proxy, again, this could be the where you may, if it's a product that you're shipping, maybe this is where licensing is handled. You don't want to burden those microservices with the cross-cutting concerns like licensing. Also, authentication, authorization, and auditing may also be tucked away in the proxy there. And the proxy really could be as you carve up a monolithic application into these distinct microservices, the proxy could be basically just kind of what's left. Each service has built-in diagnostics and performance monitoring capabilities. Yeah, this is pretty essential. And that wraps up part 3. In part 4, we will conclude the series by discussing some implementation considerations, and finally wrap up by describing what living software is or could be. Thank you.